Hi everyone and welcome back to Maths and Physics with Mr. Simons. We make maths and physics easy and we get you exam ready. Right, today's lesson is on classwork on inequalities. Right, so we're looking at the 8th variation. And this 8th variation I've broken up in parts. So first part, before we solve inequalities, we need to know how to represent inequalities, either in set builder notation, interval notation, or on a number line. Right, so we're going to test any one of the three, and we hope that you get used to our representation of inequalities. So let's look at the first problem. Right, so for inequalities, number one, if we had to represent real numbers between -3 and 2, what do I mean with between? So doesn't include -3, doesn't include 2, but it's in between the two. So in between, smaller than 2 is 1, bigger than -3 is -2. Right? So in set builder notation, curly brackets, x is such that x is greater than -3 and smaller or not equal, x smaller than 2, and x must be an element of real numbers. So x element of real numbers come from the fact that they say real numbers. They said between, so therefore no equal sign with x. Right? My two inequality signs will always face, if I have two values, will face both to the left always. And the biggest value will be on the right and the smallest value on the left. So in set builder notation, curly brackets, x is such that x is less than 2, but x is greater than -3, and x is an element of real number, close curly brackets. Now in interval notation, right, now, yeah, because the two values are not included, we're working with the open interval. So what I mean with the open interval, I have two open brackets or open parentheses, right? So there, open bracket -3, it goes till 2, open bracket. If I make that a square bracket, then that means I'm including -3, so that means it would read x is greater and equal to -3. Right? For my apologies, sketched on a number line. So -3 not included, therefore open circle. 2 not included, open circle. But we're going from all the values in between -3 till 2. Right? So that is the three ways we will test of your representation of inequalities. Right? Let's look at the second problem. Right, number 2, represent the real numbers from -1 to 7, inclusive in all three ways. Right? So I'm starting from -1, so -1 is included. And I'm going to 7, where 7 is also included, right? So in set builder notation, x is such that x is less or equal to the biggest value, 7, and greater or equal to -1. The equal sign comes from the fact that we're starting from -1 on the dot and we're going exactly to 7. Real numbers, so therefore x element of real numbers. Curly brackets for set builder notation. In interval notation, yeah, we have a closed interval because -1 and 7 is included. So to represent a closed interval, we could use what you call closed parentheses, right? Or square bracket, as you sometimes as teachers we just say, but it's closed parentheses. We start from -1 and we go till 7, right? So that's because it's equal, therefore close parentheses. Sketched on a number line, so because -1 is included, we have a closed dot. Because 7 is included, closed dot. Alright, and it's real numbers, so it's all the values in between -1 till 7. So therefore we draw a line from -1 till 7. Right, so that's the three ways. Let's go to the third problem. We want real numbers from and including -2 up to but not including 2. Right, so we're starting exactly at -2, but we're actually stopping before 2. We're dealing with real numbers, so in set builder notation, the first part will always be x is such, so that stays the same. The n there will always be x element of whatever numbers we specify. So they said real numbers, so x element of real numbers. Then minus 2 and 2 is given, so my biggest value will always be on the right and my smallest value will always be on the left. Right? X, my two inequality signs must point to the left, so x is smaller than 2 because it's not including 2. So it's smaller than 2 but not equal to 2, and x including negative 2 is greater or equal to negative 2. Right, so the equal sign there in interval notation will go with a close parenthesis. The 2 there that's with less than will go with open parenthesis. So in interval notation, x is such that it goes from minus 2 included up to just before 2. This is closed open or half open interval. So sketched on a number line, minus 2 because it's included, close dot. 2 because it's stopping just before 2, open dot because 2 is not included. And from there, because it's real numbers, I can join a line from negative 2 to 2. Alright? So there, if it's not equal, remember, very important, open bracket. If it's included, that dot there must be closed. The solid circle, open circle. Right, let's go to the next problem. Now number 4, the key difference, they say the natural numbers. No more real numbers, but the natural numbers from 3 up to 7. So we're going from 3 up to 7. So in set builder notation, x is such, that stays the same. The n there, x element of natural numbers. The middle, my two inequality signs will always point to the left. Always. No. If I write two of them, both of them will point to the left. My biggest value on the right, my smallest value on the left. Right, so x is less or equal to 7 because 7 is included, and x is greater or equal to 3. Right, now there's no interval notation. We have to list this because it's natural numbers. So listed, we're starting from 3, curly brackets, it's 3, 4, 5, 6, 7. Right, we cannot use interval notation because we're only considering natural numbers and not rational numbers in between. So sketched on a number line, starting from 3, solid dot, 4, 5, 6, 7. Can't draw a line to join them because those numbers in between 3 and 4 are rational numbers or form part of the rational number system or real number system, so I can't include those numbers. Right, let's look at the next problem. We want integers between minus 2 and 3. So in set builder notation, we want between the two, so it's not equal to it. So x would be less than the biggest value 3 and will always be greater than the smallest value negative 2. Integers, so x element of integers at the end. And the front will always start x is such, and therefore curly brackets start and end. Again, integers, there's no rational numbers. So we have to list it. We can't write it in interval notation. So listed greater than minus 2 is minus 1. 0, 1, 2, smaller than 3, I end by 2. Alright. So again, this is listed because there is no rational numbers in between, so I can't consider that. So sketched on a number line, I'm starting from minus 1, 0, 1, 2, and if you wanted to include negative 2, you can go make an open dot there and an open dot by 3 to show that 2 and 3 are not included. Right, so these are basic different variations of how to write them and so on. I hope you follow. I hope you understand. I wish you nothing but the best. God bless. Bye. See you in the next lesson.